In this video, we're gonna try to prove the following result given that a is bigger than 0 and b is bigger than 0 and a is less than b. We have to prove that the square root of a plus 1 plus the square root of a plus 2 is less than the square root of b plus 1 plus the square root of b plus 2. In fact, we have many ways to prove this result. I think the easiest way and the quickest way is to use the fact that, and we have seen that, we have proved it, that the square root preserves the order. So here we have a and b positive, and a is less than b, then we can have the square root of a is less than the square root of b. Okay, we're gonna use this twice here at least. And before that we have to do some additions. Okay, so here we have a less than b. Okay, so it's given to us. If we add 1 to both sides, we have a plus 1 is less than b plus 1. And also if we add 2 to both sides, we have a plus 2 less than b plus 2. Okay, here if we apply the square root, here we're going to have the square root of a plus 1 less than the square root of b plus 1, and also here we have the square root of a plus 2 is less than the square root of b plus 2. Okay, now we have these two numbers. Addition won't change the order, so we can add these two side by side. We have then the square root of a plus 1 plus the square root of a plus 2 less than the square root of b plus 1 plus the square root of b plus 2. And that's what we need. Okay, so this proves the result, but this is based on the fact that the square root is order preserving. Okay, here the order doesn't change. Okay, we can use some calculus here if we want to. So given that a and b are positive, we can define, and this is what we can do here if we want to use some calculus. So we can define a new function. We're going to call it f of x. It's going to be the square root of x plus 1 plus the square root of x plus 2. Okay, so this function is defined on -1 plus infinity, but since we need only the positive value, we're gonna let it be only on this domain 0 plus infinity. Okay, so here we can use some algebra to find the derivative. So here we have these two functions, both of them are differentiable, so we can differentiate. So we have f prime is 1 over 2 square root of x plus 1 plus 1 over 2 the square root of x plus 2. If I factor out by 1/2, I have 1 over 2 1 over the square root of x plus 1 plus 1 over the square root of x plus 2, and this quantity is bigger than 0. Why? Because these two quantities are bigger than 0. So f prime is positive, f prime is bigger than 0. That means f is increasing. That means my function is increasing. Okay, and given that I have a less than b, therefore I have f of a less than f of b. Okay, and using my function, this gives me that the square root of x plus 1 plus the a plus 1 plus the square root of a plus 2 is less than the square root of b plus 1 plus the square root of b plus 2. Okay, so this is the using calculus and using the function. Okay, so there is a way to do things using functions. This helps in finding the result. Okay, there are other means, but sometimes you can take this one to this side and take the square, But using algebra and using calculus, we have proved the result. There are other ways to do this result, and I think we can use the other method like the geometric mean, but this is enough for us. Okay, this proves the result.